Okay, students, welcome to another class of stereochemistry. In this class, let me introduce you how to assign R&S nomenclature for three-dimensional molecules. That is the molecule not given in Fischer projection, but the molecule is given as in three-dimensional projection. Okay, it's a very simple. First, let us understand this molecule. Central carbon, INCl. Imagine INCl are on the board like this. This is I, this is Cl. INCl on the board. Okay? Now, this hydrogen, suppose you are in this direction, therefore hydrogen is away from you. Hydrogen is away from you. Therefore every dashed line groups are away from the observer. Suppose you are here, this is your eye, and this is how you are observing. I is away from your observing point. Now, where is BR? BR here. BR here. Look at here. BR here. Towards your observer. Suppose here is I, BR here, towards your observer. Therefore, we have two planes. One plane is containing these two sketches, these two ball pen, okay, and another plane is consisting of this scale and pencil. Okay, therefore you have a plane, one plane like this. Imagine a plane of board where both these whiteboard pen are on the board and the pencil away from you, scale is towards you. Whenever you see this type of three-dimensional structure, this structure should come in your mind. This structure should come. A V. Look at a V. This is a V. Another V like this. Therefore, you have an English letter V like this. Fine. And another V has clamped like this. Okay? Yes, very simple. This is a V. This is a V, two V like this. Okay. Yes. Now, very simple. You give the CIP number here. First, you have to ensure that the least priority group, that the fourth priority group should be away from the observer. The least priority group should be away from the observer. Okay. If not so, we have to do one more thing before assigning the priority. Okay. Therefore, here bromine, iodine, chlorine and hydrogen, this is the least priority group which is away from here. No problem. No problem. Therefore, you number 1, 2, 3. 1 to 2, 2 to 3. 1 to 2, 2 to 3. What is the direction? 1 to 2, 2 to 3. This is a clockwise, therefore R. Here also, I just checked in the dashed line. The dashed line, it is away from the observer. What is that group of hydrogen? This is among the least priority, 4. No problem. Therefore, please number like this. Most priority 1, 2, 3. 1 to 2, 3. This is also R. Here also the least priority away from the observer, because it least priority in the dashed line. No problem. 1, 2, 3. Therefore, this is S, because anti-clockwise. Here also least priority from away from you. Therefore, most priority 1, C2, H5 and CH3. This is second priority, third priority. Therefore, this is also R. Okay. Okay. Simple. Very simple. Now we can go to some other examples. Okay. I give you another structure like this. COOH, H, OH, CH3. The dashed line contains CH3, but the problem is that this is the fourth group. Therefore, you want to make these two here. For that, you can exchange these two. Just exchanging. Bring these two here, these two here. Therefore, you just draw like this, no problem. Okay. COOH, OH. Now we are just exchanging nothing but this CH3 here and H here. We have exchanged. Now you please number most priority oxygen 1. This priority rule has been discussed in the previous videos. Okay, remember, please go and watch it. Second goes to here, third goes to here. You are getting, this is anti-clockwise S, but you got the S just after the exchanging, after one exchanging. Therefore, your actual one is R. This is the actual one. Since you have one exchange, therefore after exchanging what you got, just reverse it. That is actual configuration. Okay? Please remember that. That is actual configuration. Therefore, this is only the care you have to take if the least priority is not on the dashed line or away from the observer. You can go one more example like that. Okay. C, Cl, CH3, H, Br. Okay, the dashed line contains Br among the most priority. Therefore, you want to exchange that. For exchanging, please take CH3, Cl. Please exchange hydrogen here and bromine here. Now please number, no problem, 1, 2, 3, fourth on dashed line. The number, this is you got R, but these are obtained after the exchange. Therefore, the actual one is nothing but S. The actual one is S. Okay. Yes. Now, one more example. COOH, H, CH3. I'm sorry, here OH. Here also, the problem is that in the dashed line you have a CH3, but this is the least priority, that should be exchanged. Therefore, we can do that. COOH, CH3. You exchange both H, then OH. Which is the most priority? 1, 2, 3. What do you got? This is S, but this S is after exchange, therefore the actual configuration is R. You have to write the answer R, okay? Please write the answer R. Suppose the jam question, what is the actual configuration? You have to write R, don't write S. Therefore, this is a correct one. Why I write S? Because the direction shows you S, but that is not the actual one. The actual one is R. Okay. Now we can go to another example like this. Suppose a molecule like this, two chiral centers, Cl, C2H5. CH3, H, Br, H. Okay. Therefore, this is one chiral center. Imagine this is one chiral center. This is another chiral center. First, we can discuss this one. Here, luckily, the last priority group, away from the observer, last priority group, hydrogen is. Therefore, we are very lucky. No confusion about it. 1. Here CH3, here a C, all this group. Therefore, this goes to the second one. This is a third. Therefore, you got it like this. Therefore, here R, no problem. But when you come here, the least priority group is bromine. But it should be hydrogen. Therefore, I just change it. Hydrogen here and bromine here for timing. We have to exchange. Now you number first, second, second C2H5, carbon, chlorine, CH3, which will be the second priority. This will be the second priority. Why? Because here carbon, here also carbon. This carbon is connected to hydrogen and another carbon. I'm talking about this is CH2, CH3. This is okay. But when you come here, this carbon connected to a chlorine, a carbon, a hydrogen. Therefore, this has the second priority, then this has the third priority. Therefore, our rotation is like this. This is S, but not S. Actually, it is R. You know why? Because you got this after the exchange. Therefore, the configuration is R and R. Very, very simple. Okay. Now, in the next video, I will explain you how to convert this 3D structure into Fischer projection. Then I think that topic will be well packed for your JAM question. Okay. Thank you for watching.